Assalamualaikum and hi everyone. We are from MEMS 12 and we will present about the thermal flow sensor. Assalamualaikum and hi everyone. My name is Ashraf Muhammad Yusof. The analysis was used to study the temperature of the sensor over time. There are three types of material that have been used as shown in figure A. The principal operation of the thermal flow sensor is gas flows by the heated flow sensor and molecules of the gas transport heat away, the sensor cools and the energy is lost. After the inputs were applied, the minimum temperature is 24.873 degrees Celsius while the maximum temperature is 177.03 degrees Celsius as shown in figure B. In graphic, there is increases in temperature for the minimum and average temperature except for the maximum temperature, the temperature is decreasing. For graph D, in the beginning, there is increasing and decreasing of the sensor temperature. After that, it will maintain its temperature until the end of the 2 seconds and the temperature will increases until it reaches 78.934 degrees Celsius in 30 seconds. In conclusion, heat can be detected from 24.911 degrees Celsius until 78.934 degrees Celsius in 30 seconds. The higher the sensor temperature, the better because it increases the range of the temperature to be detected. Lastly, this is the simulation of the transient thermal analysis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zainul Abidin Ishaq. I'm from Group 12. I will present for my project which I use material glass, nickel and gold. For my part, I will use glass, nickel and gold for my material. The reason I choose gold, it has high thermal conductivity, which is good for the sensing element. Gold have 315 watt for the thermal conductivity and the specific heat is lower other than material. For the analysis system, we use transient thermal. It was the most suitable system other than thermal electric and steady state thermal. For all three analysis, we try out of the three analysis. The initial temperature is set to 24.85 degrees Celsius and the number of steps is 30. 185.96 degrees Celsius was applied as the temperature of the heater. The reason we apply the temperature at the heater is because we cannot put a supply or the transient thermal for the solution does not have for electric voltage. If we observe the left graph, the graph represent for the input temperature with each heater temperature. We give a fixed value of temperature. For the right graph, it represent the output temperature with each sensor temperature for a step 30 seconds.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Ahmad Basri from Group 12 and I will present my project thermal flow sensor by using silver as material for the heater part. The material used for this thermal flow sensor is silver, nickel and glass. Silver for the heater part, nickel for the sensor part and glass for the body. Transient thermal analysis was used for this project. The input used for this analysis is temperature applied on the heater and the convection. The initial temperature is 24.85 degrees Celsius and the temperature applied on the heater is 176.85 degrees Celsius. While for the convection, the flame coefficient is 5W over M2 degrees Celsius and the ambient temperature is 24.85 degrees Celsius, which is same with the initial temperature. From the simulation result, the temperature versus time graph of all bodies temperature shows three output graphs, that is, minimum temperature, average temperature and maximum temperature. For minimum temperature, the red graph, the temperature increased from negative 16.18 degrees Celsius to 24.894 degrees Celsius by referring the tabular data in ANSYS. For average temperature, the blue graph, temperature increased from 54.511 degrees Celsius to 72.228 degrees Celsius. But for the maximum temperature, the green graph, the temperature decreased from 180.66 degrees Celsius to 177.05 degrees Celsius. For the sensor temperature, based on the temperature versus time graph of sensor temperature probe in ANSYS, the sensor temperature decreased from 32.976 degrees Celsius to 24.778 degrees Celsius for 1.74 seconds. After that, the sensor temperature increased from 24.778 degrees Celsius to 62.728 degrees Celsius for 30 seconds. MEMS thermal flow sensor in fight against COVID-19. During this pandemic, any machine related to the medical must be always monitored to make sure it can operate for a long time. When there is increasing in time, there will be more heat flow that can cause the machine to damage. With this type of sensor, the temperature of the head can be monitored, including the heat flow. Other than that, with a little adjustment, it can be placed in a room to monitor the temperature of the room. For example, the limit of a person in a room must not more than 10 people. If there are more people in the same room, the sensor can detect the heat flow of the room and can alert the authorities.